Okay, this is a rectangular area is to be enclosed by a wall on one side and fence on the other 3 sides. If 18 meters of fencing are used, what is the maximum area that can be enclosed? So a rectangular area is enclosed by a wall on one side. So let's make this. There's my wall. Okay, this is my fence. And 18 meters of fencing are used. So right now, I need to call that a variable, and that a variable. And I know that 2x plus y has to be 18. Okay, that's called a constraint. You obviously don't need to label this, but that's a constraint. And we're trying to find the maximum area. So we want to maximize area. So I want my area to be maximized. I want it as a function of one variable. Right now it's xy. That's not a function of one variable, but we use our constraint. So y, over here we know y is equal to 18 minus 2x, which I can take and put right here, and then I can write a of x. So now I can say a of x is equal to x times 18 minus 2x. Okay, now, we can think about, typically you should start thinking about the domain here. Like obviously x needs to be positive if you think about it, right? This is a multiple choice, so you can kind of skirt through and not have to do some of the technical things you would want to do if you're showing all your work. But for the record, we want x to be a positive number, of course. And we want y to be a positive number as well, which means that 18 minus 2x has to be a positive number, which means 18 has to be bigger than 2x or dividing by 2. Right, and so putting these things together tells us that we're looking for our answer in this window. This would be the domain of our function. Okay, but now we use calculus, right? So we note that a of x, I'm going to distribute this. So using calculus, we'll use the first derivative test, taking a derivative, giving us 18 minus 4x. Find critical points by setting equal to 0. And then here I have that 4x is 18, or x is 18/4 or 9/2. Now, what does the question ask? It says, what is the maximum area? So, we can be pretty sure that we found the critical point that we care about. First of all, this is a parabola. It's a parabola that opens down, so it's going to do that. So I think we found our max, but to be thorough, just for this example, I've already restricted my domain to be from 0 to 9. Okay, and a prime of x, we've got a critical point at 9/2. And if I plug in, for example, plugging in 0, something to the left of 9/2 into my derivative, I get a positive number, which means my function is increasing. And then if I plug in, for example, 9 into my derivative, 18 minus 4 times 9 is a negative, which means my function's decreasing, which means I found a max by the first derivative test. All right. All this work is not really required for this multiple choice. You could probably just go right ahead and plug in 9/2 into the area function. So we know we have a max at 9/2 by the first derivative test. And now I got to find that max area by plugging in. I got to plug 9/2 in. So using a little bit of, this divides and gives you 9. So now I have 81 minus, and this is 2 times 81/4. So this is now 81 minus, let's make this, 81/2. So that's, so this is 81 minus 81/2, which is 162/2 minus 81/2, which is also 81/2. And so 81/2 square meters should be our answer. And that's answer choice E.